Are we into the sixth mass extinction, where large numbers of the species of the Earth, maybe including us, will be wiped out? Campaigners say so. Well, campaigners say all sorts of things, but then similar messages are also repeated by a number of scientists. Sounds rather important. We should probably know what's going on, so let's have a look. If we're talking about the sixth mass extinction, the clue is in the name that there may have been others. You would guess 5, and you would be sort of right. There have been more smaller events, but there are the 5 big ones. So let's just talk about what such events have entailed in the past. The most recent is, of course, the most famous. 66 million years ago, the end of the dinosaurs and much else besides. In this case, it came as a result of a major asteroid or comet impacting the Earth at a speed estimated to be around 67,000 miles per hour, hitting the planet with a force of over 100 trillion tons of TNT. Steve Brusatte painted the picture in his excellent book, The Rise and Fall of the Dinosaurs. The first flash of light occurred as the asteroid punched through the Earth's atmosphere and violently compressed the air in front of it, so much that the air became 4 or 5 times as hot as the surface of the sun and ignited. The second flash was the impact itself when the asteroid met bedrock. The sonic booms followed many hours later. With them came the winds, which probably blasted at over 600 miles per hour close to the Yucatan and still at several hundred miles per hour by the time they reached Hell Creek. For comparison, Hurricane Katrina's maximum wind speed was measured at about 175 miles per hour. Shockwaves shook the ground like a trampoline, probably around 10 on the Richter scale, more powerful than seen by any human civilization. Long may it remain so. These triggered Atlantic tsunamis. House-sized boulders were flung about. Volcanoes were pushed into hyperdrive, and they kept erupting for thousands of years. And so he goes on. Liquefied rock rained down, transferring heat to the atmosphere, turning it into an oven. Forests then ignited, wildfires swept the land. The fact that the dinosaurs died out, it's not a surprise. 75% of all species died out. The miracle is that anything survived at all. Although most members of all species will have died, some individuals made their way through. Frogs, salamanders, lizards and snakes, turtles and crocodiles, a few smaller mammals, and those dinosaurs that had the foresight to evolve into birds. Along with sea-living invertebrates and fish. What did the survivors have that helped them get through? Well, they were smaller, they had more omnivorous diets, being able to hide in burrows or stay underwater and eat many different things was an advantage. Not enough of an advantage for most of them, just enough for some. The sun was then hidden for years by soot and rock dust. Photosynthesis shut down. The darkness brought a long, cold winter. But there were still things that could live off decaying plant matter, and there was plenty of that. But for the rest, food chains collapsed as plants died, leaving a post-apocalyptic wasteland that would take millions of years to recover. That wasn't even the worst of them, by the way. The end Permian extinction event, which happened 252 million years ago, up to 96% of all species were dispatched by that one, which spread over a longer time frame in 3 pulses. The exact causes of those pulses are not certain, may have included a meteor strike, extended volcanic eruptions, and rapid climate change brought on by sudden releases of methane, amongst other things. So, let's be clear, that's what we're comparing with. And you might look around you today and think that the world today doesn't especially resemble such nightmare scenarios. And you'd be right. But bear in mind that something that seems abrupt on a geological time frame can still take place over thousands or even millions of years. So yes, the dinosaurs one day woke up to probably the worst single day on the history of life on Earth. But not every mass extinction was so obvious when it first started. The 5 extinction events ranged between 50,000 and 2.76 million years in duration. But the point was that they entered a chain of events. where one consequence inevitably followed from another, and gradually the amazing, stable, life-nurturing circumstances of our planet were completely undermined. Given the major impact the human race has had on the planet, and the promised additional impacts from human-caused climate change, various people have been predicting that we are already within such a chain of consequences. Elizabeth Kolbert, the author of the book The Sixth Extinction, An Unnatural History, predicted that we are in the crosshairs. By disrupting these systems, cutting down tropical rainforests, altering the composition of the atmosphere, acidifying the oceans, we're putting our own survival in danger. Campaigners now refer to such a process in passing, as though the reality is widely known and universally accepted, such as Extinction Rebellion spokesperson Rupert Reed in his book This Civilization is Finished, where he says this: as the consequences of industrial growthism leads us steadily towards the white swan of climate catastrophe and ecological breakdown, with the sixth mass extinction well underway at our hands, surely we have to reassess this assumption. But is the sixth mass extinction, quote, well underway? The scientific respectability for such a claim comes from papers like this: Biological annihilation via the ongoing sixth mass extinction signalled by vertebrate population losses and declines, by Ceballos et al. 2017. The paper's abstract certainly feeds the campaigners' certainty. The population extinction pulse we describe here shows from a quantitative viewpoint that Earth's sixth mass extinction is more severe than perceived when looking exclusively at species extinctions. Therefore, humanity needs to address anthropogenic population extirpation and decimation immediately. We find that the rate of population loss in terrestrial vertebrates is extremely high, even in species of low concern. In our sample, comprising nearly half of known vertebrate species, 32% are decreasing, that is, they have decreased in population size and range. In the 177 mammals for which we have detailed data, all have lost 30% or more of their geographic ranges, and more than 40% of the species have experienced severe population declines. Our data indicate that beyond global species extinctions, Earth is experiencing a huge episode of population declines and extirpations, which will have negative cascading consequences on ecosystem functioning and services vital to sustaining civilization. We describe this as a biological annihilation to highlight the current magnitude of Earth's ongoing sixth major extinction event. And they haven't changed their mind since 2017. This paper from the same authors in 2020 makes a point. Thousands of populations of critically endangered vertebrate animal species have been lost in a century, indicating that the sixth mass extinction is human-caused and accelerating. As you would expect, this then feeds into more popular articles like this. According to a recent analysis, the sixth mass extinction of wildlife on Earth is accelerating. More than 500 species of land mammals are on the brink of extinction and are likely to be lost within 20 years. The same number were lost over the whole of the last century. The scientists say that without the human destruction of nature, this rate of loss would have taken thousands of years, and they warn that this may be a tipping point for the collapse of civilization. Always beware of sentences that have the word may in them. They are by definition speculation. But it's not as though there isn't a serious issue here. Let's look at some of the sober detail. In the past 3.7 billion years, a time scale that none of us can really comprehend, millions of species of an astonishing diversity of life forms managed to evolve. Right now, as we sit here today, the number of species is thought to be the largest in the history of life, according to papers such as this one by Burrow et al. In 2004. But broadly, we've seen a pattern through history. Life emerged, evolution took it into various pathways to fill in whatever survival niches existed. Species evolved to better suit all the different microclimates. Where there were some species, some would emerge to become predators of those species, and so on. And when a mass extinction event occurred, space would be cleared. Then over hundreds of thousands or even millions of years, gradually evolution would do its thing and those niches would be filled again. Now we have a new situation. one species has become wholly dominant, able to rise above the immediate constraints of the environment, and has consequently spread and multiplied to a degree that no species on this planet has ever done before. That alone means that we are into new territory here on planet Earth. What came before isn't necessarily what comes next. For better or for worse, nothing is now ruled out. Now is the time when we need to see clearly what is happening to our world. But when it comes to monitoring species extinctions, we've got something of a problem. How do you know when the last of a species dies? Because, generally it happens out of sight. We've seen some animals that were thought to have been extinct for decades suddenly turning up in some odd corner of a rainforest somewhere. We've seen a number that we haven't seen for a while. How long before you decide that they're almost certainly gone? The convention has been 50 years. Fail to see a single member of a species for 50 years, then we'll count them as extinct. The problem with that is that then your running count of what is or isn't going extinct, it's running with a 50-year buffer. That's not ideal either. And that's what that initial paper by Ceballos et al. Is really addressing. It's pointing out that counting extinctions isn't really the way to take the pulse of the natural world right now. The one thing we do know is that the quantity of animals has been in significant decline. Because look, if 75% of the members of a species have been lost, the species is still a long way away from being extinct. But, it's a major change. And not a good one, obviously. It's a significant weakening of that species in its resilience in the future. And that much is incontrovertible. Large percentages of populations have declined, mostly in line with the loss of natural habitats as humans have increased in number and filled in more and more space. It's a situation where many have looked at the rate of decline, they've drawn a straight line to follow the trend, and then projected that these species are all going to go and die out within a relatively short time frame. But if species decline is down to habitat loss, and so far research suggests that that is overwhelmingly the case, then it will track future habitat loss. It won't just keep going on its own momentum. And that's what we've seen in recent times, where habitats are restored, recreated or protected, wildlife often responds positively. So that's good news, because at least as far as that goes, we're in a perfectly good position to protect most of those habitats. But the key challenge here really is the quantity of things that we just don't know. As you have with any situation where you have complexities playing out of sight, scientists have been trying to project future extinctions by resorting to computer modelling. The challenge is always what sort of parameters you feed into your model and whether they reflect the real world sufficiently to be able to make prediction possible. Models tended to make assumptions about the number of species that would be lost given a certain amount of habitat destruction, the so-called species area model. This led to the situation over the course of around 30 years or so, when it was suggested that we were losing up to 100 species a day due to the loss of tropical forests, which sounds a lot more significant and alarming, particularly in the face of the fact that less than 1,200 extinctions have been recorded in the last 400 years. Then scientists also calculate what in a normal environmental situation would be the background loss of species that you'd expect to happen anyway. And it's an extremely low number, somewhere between 0.1 and 1 species extinction per 10,000 species per century. So even a few extinctions per year reflects a massive increase on that assumed background rate, and that becomes the rationale for those scientists in making some of those bigger claims. If we're losing species faster than evolution is producing them, then over geological timeframes that turns into a mass extinction, which is true if it continues unabated, and we're talking about long timeframes. Now, it's a long way from people's popular perception that it means that species start dropping like flies within the next generation. The point is that in the past, species reduction came about because of some environmental change, a major change, and there was then a domino effect of consequences. But if enhanced species loss has been caused by one-off changes, humans moving into spaces destroying habitat, but then we stop destroying habitat and even intentionally restore some of it, then whether species extinctions continue depends on whether or not we pass some sort of tipping point in the meantime, where we've started consequences we can no longer control. Now, so far, we don't seem to be that far on in establishing where such tipping points would lie, and there's no evidence to date that we've hit one of them. And indeed, those computer model assumptions that we've been using for decades have been shown largely not to match reality, largely because they were influenced by what happens to species on relatively isolated islands, because it's easier to tell when something has gone extinct on an island. But such island environments are significantly different to elsewhere, precisely because they're isolated. In this paper in 2009, Nigel Stork observed that species have proven to be more adaptable and mobile than the computer models assume, and therefore real-world observations don't remotely match up to the computer predictions. The joker in that particular pack would be climate change, because while habitat destruction is a local phenomenon, assuming you don't wipe a habitat wholly from the face of the earth, climate change is, on the other hand, a global phenomenon. Right now, the impact of climate change in advancing species loss is largely a projection based on expected future warming, not on current observation. But given the factor that rapid climate change played in some of those previous mass extinction events in prehistory, it's a possibility that you have to treat with respect. The assault on the computer models with the species loss per area equation continued with this paper, although it's worth noting that it also said this: although we conclude that extinctions caused by habitat loss require greater loss of habitat than previously thought, our results must not lead to complacency about extinction due to habitat loss, which is a real and growing threat. What about that climate change component? The most recent comprehensive review, published in April 2020, does not suggest that we are in a sixth mass extinction on that front. It found that less than 2% of species assemblages will undergo collapse from climate change if the planet's warming is kept below 2 degrees C of pre-industrial global average temperatures. If we failed on that mission to a massive extent and warming reached 4 degrees C, then the number would rise to around 15%, which would be extremely unfortunate, not to be understated or underestimated, but it would still be a long way away from the mass extinction event of the sort that you find in the geological record. And it's not just so-called lukewarmists like Michael Schellenberger that are saying that, but also mainstream climate scientists such as Michael Mann and Zeke Hausfather, who don't believe that the evidence supports the six mass extinction speculations. Smithsonian paleontologist Doug Irwin went further and called such speculations junk science. Irwin is one of the world's experts on the end Permian mass extinction, and he was interviewed by The Atlantic. People who claim we're in the sixth mass extinction don't understand enough about mass extinctions to understand the logical flaw in their argument. To a certain extent, they're claiming it as a way of frightening people into action, when in fact, if it's actually true that we're in a sixth mass extinction, then there's no point in conservation biology. He also warned against making too concrete assumptions about how much life was and wasn't lost in previous mass extinctions. To illustrate the point, he pointed at the passenger pigeon, an icon of modern extinction, a bird that was formerly numerous that we managed to wipe out. So there are estimates of what the standing crop of passenger pigeons was in the 19th century. It's like 5 billion. They would black out the sky. So then you ask, in a non-archaeological context, how many fossil passenger pigeons are there? How many records are there of fossil passenger pigeons? 2. So here's an incredibly abundant bird that we wiped out, but if you look at the fossil record, you wouldn't even know that they were there. The point is that the fossil record is a tiny echo of what was the abundance of life in previous ages. Most of the animals in the fossil record are marine invertebrates, like brachiopods and bivalves, creatures that were widespread and with strong skeletons that could make it into a fossil. We really only know about the mass extinctions because of these marine invertebrates. How many such invertebrates have gone extinct in the modern process? Pretty close to 0, according to Irwin. We're a long way from the hellscape that was the end Permian mass extinction. Doug Irwin's point wasn't that such a thing could never be caused by us, and that therefore we can all be complacent and just go around keeping doing whatever it is we want to do, but we're not currently in that cascading sequence of consequences, and the factors that decide whether or not we end there seem to be largely still within our influence. The number of designated protected areas in the world has now more than doubled to 245,000 in just 2 decades. Some will be more successful than others, but the point is that as a species we're clearly seeing a will to arrive at some sort of equilibrium between us and the natural world, particularly as the growth in human numbers flattens out. The high profile of concerns that we're essentially at the end of days and in the middle of a massive catastrophic event is just another example of how bad the human race is at estimating risk and consequences. We need to keep an eye on this. We need to put in energy and ingenuity into conservation, often in the face of political pressure pushing the other way. It's not necessarily easy. We are in a position that justifies concern. It's just not one that justifies panic. The blight that widespread fear-mongering is bringing to the lives, particularly of young people, is currently a worse problem than the 6th mass extinction. And it's also a problem that we could also solve. Not least by, avoiding making it worse.